Okay, so let's recall a few things here, what we did yesterday. We talked about exponential equations, right? And we said that the exponential equations, they have the form of what? What did we say? They have the form of what? Perfect. And then we said that A is the initial, B is the
base.
what? How does what is B? Like how can I find B?
It's the first ratio.
It's the first ratio if I know my y values, right? So if I do know my y values and I did y2 minus y1, then I can do the first ratio here. Did we talk about the different kind of equations? So we talked about also the growth and decay given a ratio. You remember that? Or giving a rate, not a ratio. Okay? And we said that if you have growth, exponential growth, and you have a rate, what would the formula look like?
Y equals A1 plus I raised to X.
And we said you might see this same equation with different letters, right? So if I open, for example, the grade 12 or the grade 11/12 formula sheet, and then I look at the finance formulas, I see P equals A1 plus I to the power of N. That's the same thing. P equals A equals P1 plus I to the power of N. It's just using different letters. The formula setup is still the same. Okay? The formula setup is not changing. Now, I is what? What is I? What's I? The rate. And how can I put the rate? So give me an example of a rate and how do you put it in?
80% is 0.8.
Okay, so if you have, let's say, 80%, right? That's your rate, right? So you're going to put it in as 0.8. That's what I is. Okay? And then what did we say the A is? The initial, and then y and x are your variable, right? So you will solve for y given x or vice versa. How about exponential decay? So it will be y equals a 1 minus I to the power of x, right? Now, these are, if I know the rate, these are the formulas that I use. Have we talked about the double and the half-life, the special cases? Have we talked about these? No. It looks like we have. All right. So other than these two formulas, we also have the special formulas, which are the double formula or the half-life formula. Okay? And these cases, you see them a lot when it comes to, okay? In the science, you see a lot of the use of these formulas. So if the question says doubling, it's doubling, okay? So the formula or your population or your the mass or whatever it is, it's doubling in a certain period of time. Your formula will be y equals A. Because it's doubling, what do you think your base is going to be? 2. Now the difference here is your exponent is going to be x divided by d, where d is your doubling time. Which mean in this case, if I say, for example, this is an example. You have bacteria culture of 1,000 bacteria, and your count is doubling every 5 hours. Find an equation for this scenario. Or for this situation. So my bacteria count is 1,000 and the bacteria is doubling every 5 hours. So where is your hint, or where is the word that you need to say, oh, it says doubling, or it says this, then I have to use this. What's that keyword that you're looking for? What's that keyword? No. Doubling, right? Because it says doubling, then you know right away that you're going to have to go to this formula right here, okay? Because it's telling you that it's doubling. So it's giving you the rate. It's giving you your base, okay? Now, what else do I know? The initial, which is what? 1,000. What else do I know?
Every 5 hours.
So what is that every 5 hours?
X. D.
It's D, because that's your doubling time. So every 5 hours, your number is going to double. So you're going to start with 1,000. Then what's going to happen after 5 hours? How much are you going to have? You start with 1,000. You're doubling times 2, which is what? 2,000. Now another 5 hours, you're going to double again, which is going to become 4,000. Right? So the 5 hours is your doubling time. Okay? You won't have the double number until it reaches the 5 hours. So 5 hours, 10 hours, 15, 20, right? These are your increments. Now, I know that y is equal to, so to set up the equation, y equals to, I replace a with a,
1,000.
it's doubling, so my base is 2, to the power of x over 5. Because that 5 is your doubling time, so that's your d value. Okay? This is my equation. I have y and I have x. Now a follow-up to this question could be, how many bacteria will you have after 24 hours?
You changed the 5 before.
Why? Is it now doubling every 24 hours? Okay, so the follow-up question to this, part B, is,
Oh, 24 goes with the X.
how many bacteria you have, how about if I say it this way, you have after 1 day? So what do you do?
Use the same formula, but you plus 24 with the X.
Now, even though I said 1 day, you have to plug 24. Why do you have to plug 24?
Because 1 day is
Because your unit has to match between the two, right? If this is in hours, then this has to be in hours, right? If the 5 is hours, then x has to be hours. Otherwise, you won't know how many times it's going to double. Okay? So in this case, I will have y equals 1,000, 2 to the power of 24 over 5. Does that make sense to you? And then what would be your answer for this? What do you do first?
You just write the exponent first.
So all of you have good calculators, so you can actually do 2 to the power of 24 divided by 5, right? And then multiply by 1,000, right? So the important part is that this part, the 2 to the power of 24 over 5, has to be done before you multiply by 1,000. But if you have good calculators, you should be able to enter it all in the calculator, and then we'll do it for you. 27,857?
Why, how do I get 24?
Yeah.
Why are you doing 24 to the power of 24? Okay. So you can do 1,000, bracket, 2, close bracket, power, and then 24. Okay, so you should have about 27,875.
Oh. Did I?
What, 57? So this is a question where you have to use the doubling equation, okay? So yesterday we looked at the rate, so the one when I give you a rate, which is percentage, and we said you can use either or. But then this, which are the doubling, they have their special case formula where the base is 2 already, okay? But also on top of that, you have to divide your x by the doubling time. If your doubling time is 1, x divided by 1 is x, right? If your doubling time happens to be 1, then things are going to be easier, right? Now, other than the doubling, we also have the half-life, okay? A lot of time, or a lot of chemicals, they have half-life. So half-life are the time that it takes for half of the amount to disappear. Okay? So doubling, you're multiplying by 2, you're doubling. Half-life is you're halving it. So if you want to come up with a question, with an equation for the half-life, what do you think the equation would look like? So y equals to what? Do you think I'm going to have an initial value? A? Okay. What would be my base for half-life? A half. 1 over 2. And then my exponent is x over, now we call it h because just to represent half-life time. Okay? So this is the same formula, except instead of doubling, I have half-life. Okay? So the h here represents the half-life time. So here's an example. So carbon 14, it's a name of a chemical, of a element. Carbon 14, it's one kind of the carbon. Okay? When you see names like this, carbon 14, that's one thing. That's the name of it. Carbon 14 has a half-life of, I'm just making up numbers here, okay? This is not true. Have a half-life of 54 years. Okay? Let's say you have a sample of 200 milligram. Write an equation to represent this situation. half-life question, right? It does say right there, has a half-life. It can't be any how do you say, like any more straightforward than this. It says it in the question, okay? It says half-life, then I know I have to use my half-life formula, okay? Now, what do I know about these numbers, the 54 and the 200? What do they represent? 200 is your initial, the A, and what does 54 represent? The H, that's the half-life time. So every 54 years, you're going to lose half of your amount. Does that make sense to you? So you have, let's say, 100 gram. After 54 years, you're going to end up with 50. Another 54 years, you're going to end up with 25. Another 54, you're going to end up with 12 and a half. So you are decreasing by half every 54 years. So let's write the equation. Y equals 200, 1/2 x over 54. So you want to know how many milligrams you have left after, give me a number of years. You're halving it after 54. So give me a big number. After 100 years, after 200 years. Give me a number.
108.
After 200. Okay. So, how much carbon 14 you will have, you won't be alive, but you'll have after 200 years. Maybe your kids can, your grandkids can do that. Maybe your, I don't know, great. I don't know. Anyway, so what do you do here? Yeah. Plug in 200 into X and happen to be the same as this, but you know what? Let's make it 180 years, just because I don't want the numbers to be mixed up here. Okay, so you're gonna plug in 180 into X, and then still divide by 54. Okay, so do that in the calculator and tell me what your answer is.
What? So X is always.
I know it's between 25 and 50, I think.
19.
No. Wait, so you have 3 in a bit. So you're going to reduce it 1, 25. What is it? 19?
19.84.
Because we're going to reduce it 3 and a bit times. Let's see.
Carbon? Oh my gosh.
Okay, make sure you know how to enter it in the calculator. Put the 180 over 54 in brackets.
Oh, the 54 should be in back.
The 180 over the 54 in bracket. Guys, for you, the ones that you guys have good calculators, do this. Literally, this is what you're gonna do. 200 bracket. Then you're gonna press the button that shows you this. Right? You're gonna do 1, 2, and then you're gonna press the power button. Close the bracket. You're gonna press the power button. You're gonna put 180 over 54. Okay, what do we get? I want everyone to enter it in the calculator to make sure that you know how to find it in the calculator. Yeah, 19.8.
200 brought in. Can I put 0.5
Yeah,
to the power of?
so you can put 200 bracket 0.5 to the power of 180 divided by 54 should be in brackets. For those of you who don't have these calculators. Yeah?
I should have just bought the expensive one.
How to put a 2 here?
So.
Just bring it down a little bit. Okay, and then if you want to get out, you use this. Go up and then put the bracket, and then push your power button, want for the power, you can also do this. Which gives you 1 over
19.8,
4.
is that right?
Yes. Yes, 19.8.
So if it's decay, it's the half-life.
It is a decay. This is a decay question, but then it has to specifically say half-life. That's the only time you can use this question. If it doesn't say half-life, you can't use this question, even if it's a decay. You have to have the special cases to use these ones. Okay? It is a decay question, but it's a special decay question. Can I be specific than this? Okay, so one equation, 2, and then you have the decay with the rate, the growth with the rate, and then this is your just general format.
Can you scroll down?
Can you read this?
Yeah, I just want the half-life.
Let me just do something 1 second.